हेलो स्टूडेंट्स एंड माय डियर फ्रेंड्स, आज से मैं एनसीईआरटी के एक अलग प्लेलिस्ट स्टार्ट कर रहा हूँ। इन दिस सीरीज आई एम गोना स्टार्ट करंट इलेक्ट्रिसिटी सॉल्व्ड एनसीईआरटी, पहला वीडियो होगा। फिर देन देयर आफ्टर करंट इलेक्ट्रिसिटी के लिए ही, ऑफ कोर्स इट इज फॉर क्लास 12 सीबीएसई एनसीईआरटी एक्सरसाइजेस हमारा नेक्स्ट वीडियो होने वाला होगा। आइए चलते हैं। इन सॉल्व्ड एग्जांपल्स को आप अच्छे तरीके से आप मैनेज कीजिए। फिर उसके बाद कोई डाउट हो तो you definitely you can comment and then thereafter फिर अगर कुछ क्वेश्चन में क्लैरिटी नहीं भी होगी तो अगेन एक्सरसाइजेस करते करते आप काफी ज्यादा क्लियर होंगे। एंड ऑफ कोर्स दीज सॉल्व्ड एग्जांपल्स एंड एक्सरसाइजेस दोनों के लिए आप जेई को भी ध्यान में रखना। सो ऑल द बेस्ट। So here comes example 3.1. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area. From the question's language, average drift speed of conduction electrons in a copper wire. That means given I is 1.5 ampere, cross-sectional area 1 into 10 raised to -7 मीटर स्क्वायर, और हमें एवरेज ड्रिफ्ट स्पीड मालूम करनी है। इलेक्ट्रॉन्स कॉपर वायर, तो हमें n पहले मालूम करना होगा बिकॉज ड्रिफ्ट स्पीड से रिलेटेड या तो वी हैव I इज इक्वल टू NEA VD एंड VD इज -EE tau by m। हमारे लिए दिस ऑप्शन इज क्लोज्ड। और कौन कौन सी चीज गिवन है यहाँ पे? डेंसिटी भी गिवन है। डेंसिटी ऑफ कॉपर इज गिवन एज 9 into 10 raised to 3 kg per cubic meter and its atomic mass is given 63.5 U. U is atomic mass unit. तो drift speed is equal to I by NEA। अब हमें इससे ही ये वर्कआउट करना पड़ेगा। N is number density, E इलेक्ट्रॉनिक चार्ज, क्रॉस सेक्शनल एरिया भी हमें सीधा पुट करना है। नंबर डेंसिटी ऑफ फ्री इलेक्ट्रॉन्स मींस नंबर ऑफ फ्री इलेक्ट्रॉन्स पर यूनिट वॉल्यूम। तो यहाँ पे मोल कॉन्सेप्ट इन्वॉल्व हो रहा है एंड नंबर पर यूनिट वॉल्यूम। अब नंबर के बारे में कुछ भी बात ही नहीं की गई है क्वेश्चन, लेकिन उससे रिलेटेड एक चीज दे दी गई है, डेंसिटी एंड इट्स एटॉमिक मास, यानी कि वन एटम का मास इज 63.5। तो मोलर मास यानी कि 1 मोल, यहाँ के डेटा से ये पता लग रहा है कि अगर 63.5 ग्राम कॉपर लिया जाए तो उनमें कितने नंबर ऑफ एटम होंगे, कॉपर एटम। ये कैलकुलेशन जरा अब हमें समझना पड़ेगा। दिस इज बेसिकली मोल कॉन्सेप्ट फ्रॉम द गिवन डेटा। अगर एटॉमिक मास 63.5 है, दैट मीन्स, जो कि बेसिकली आप केमिस्ट्री के कैलकुलेशन में पढ़ते हो, 63.5 ग्राम कॉपर इज इक्विवेलेंट टू 6 into 10 raised to 23 copper atoms. Density is mass per unit volume. तो हम लोग मास तो मालूम कर ही सकते हैं, हाँ? 1 एटम का मास यानी कि अपॉन 6 into 10 raised to 23 ग्राम। Number of free electrons per unit volume of the conductor. That means in denominator we are to consider volume of the conductor and for volume mass per unit density, and each copper atom has 1 free electron. So hence total number of free electrons is 6 मोल कॉन्सेप्ट के हिसाब से 6 into 10 raised to 23। अब volume is mass and mass is 60। since we are considering 1 mole का mass is 63.5 gram and per unit density mass per unit density, and density was also given 9 into 10 raised to 3 kg per cubic meter. Then afterwards 6 into 10 raised to 23 into 9 into 10 raised to 3, but here this number is expressed in terms of gram, 63.5 gram. तभी तो here also ग्राम का मतलब 63.5 upon 1000, 6 into 10 raised to 23 to 9 into 10 raised to 6 upon 63.5. Now afterwards I have to calculate. Bring my calculator. Finally we have 29. Do one thing. 9 6 are 54 upon 63.5. It is 850. 54 divided by 63.5. ठीक है 0.850 into 10 raised to 29. It implies that n is 8.5 into 10 raised to 28. अब अगर वापस से अगर हम बात करें from this equation, Vd is equal to I upon NEA, then Vd is equal to, up directly, I is 1.5 ampere, N is 8.5 into 10 raised to 28, E is 1.6 into 10 raised to minus 19, to A was 1 into 10 raised to minus 7. Now we need to multiply this only 1 upon 1.5. No, पहले 8.5 into 1.6. So 1.5 upon 13.6 into 10 raised to 7 कितना होगा? 10 raised to minus 26 upon 13.6 is 0.110 into 10 raised to minus 2. 1.1 into 10 raised to minus 3 meter per second. फिर उसके बाद it could be written as 1.1 into millimeter per second. Now हम लोग सेकेंड पार्ट पे आ जाते हैं. सेकेंड पार्ट में ए पार्ट में एवरेज स्पीड पूछा था, एवरेज ड्रिफ्ट स्पीड. बी पार्ट में दे आर आस्किंग अस टू कंपेयर द ड्रिफ्ट स्पीड obtained above with thermal speeds of copper atoms at ordinary temperatures. तो पहले तो अब बी पार्ट में, तो इसके लिए अब हमें थर्मल स्पीड निकालनी पड़ेगी. एंड वन फॉर्मूला फ्रॉम द चैप्टर काइनेटिक थ्योरी ऑफ गैसेस इन 11th, एंड वहाँ पे हमें हाफ mv² को 3/2 kBt से इक्वेट करके हमें एक फॉर्मूला मिला था. दैट वाज थर्मल स्पीड और RMS speed of electron having the kinetic energy half mv². So half mv² is equal to 3/2 kBt, where T was temperature, M was mass, V was speed, वही same speed. अब KB was Boltzmann constant. Yes, you are right. तो फिर हमें V हमें जो मिला था वो kBt/m. तो इससे thermal speed of copper I approximately, because this is not taught in the question, it is roughly taken room temperature का equivalent. And lastly, calculation of M, 3 kBt, 1.38 into 10 raised to minus 23 to 300 Kelvin on 10 raised to minus 3.6 into 10 raised to, and it will come over here and it will be directly cancelled. this factor I am directly cancelling, right? Then thereafter is root under 3 into 6 into 1.38 into 300 on 3.5 to 10 raised to minus 3. It should come approximately 342 overall, but it should not come this value. And that is root under 100,354 point is equal to, और इनका कंपैरिजन भी करना था, तो कंपैरिजन करने के लिए was 1.1 into 10 raised to minus 3 meter per second. Therefore, required ratio would be of free electrons upon the RMS of per atom, and 342.57. And after calculation, so right now we are into second part of this question, and this is B part. In B part it is first part. In B part it is first part. Compare the drift speed obtained above with thermal speeds of copper atoms at ordinary temperature, which we have found speed of propagation of electric field along the conductor, which causes the drift motion. B second part, to compare the speed of propagation, electric field along the conductor. Electric field, and this is very important, very interesting point. Electric field propagates along a conductor with the speed of EM waves, EMW. That means we are to compare. Required ratio would be VDC. That is equal to, already we had this 1.1 into 10 raised to minus 3 upon 3 into 10 raised to 8. Just final answer would be again approximately 10 raised to 11. Final answer. Now for example 3.2, this is appearing completely theoretical, but still let's see. There are 5 parts in that. A part in example 3.1, that means previous question, the electron drift speed is estimated to be only a few millimeter per second for currents in the range of a few amperes. How then is current established almost the instant a circuit is closed? That means इतनी जल्दी करंट कैसे जनरेट हो जाता है? अगेन इनके लिए फैक्टर है इलेक्ट्रिक फील्ड. The deciding factor is electric field, and in previous question B2 second part, we had this electric field in numerical format. Now same electric field we are to discuss for this first part. So for this part, for current generation, they don't have to wait for electrons. Then second part, the electron drift arises due to the force experienced by electrons in the electric field inside the conductor. But force should cause acceleration. Why then do the electrons acquire a steady average drift? This is basic fundamental for acquisition of drift velocity. Let's come to, that means we need to explain the reason behind this average despite uniformly accelerated motion. Does accelerate drift speed collides positive ion, and this collision only cause obstruction, that is resistance inside the conductor. It loses its drift speed after collision but starts to accelerate, increasing its drift speed. Therefore electrons acquire. And now third part, if the electron drift speed is so small and the electron's charge is small, how can we still obtain large amount of current in a conductor? This is again very thoughtful question because the electron number density is very high, in the order of 10 raised to 29 per cubic meter. The reason further I am to give one reference. I is equal to NEAVD. That means current is depending upon N also, and N is this much high. Then come to D part. When electron drift in a metal from lower to higher potential, does it mean that all the free electrons of the metal are moving in the same direction? Yes, that is obvious. It has to. So this was D part. D part में the drift velocity is superposed. Then come to E part. Are the paths of electrons straight lines between successive collisions with the positive ions of the metal? In the first, absence of electric field, presence of electric field. That means in both the situation, it has been asked whether the movement of electrons paths are a straight line or not in both the situations. Absence of electric field maybe and presence maybe. E part, electric field, the paths are straight lines. And hence this question number 3.2 is over. Then 3.3, an electric toaster uses nichrome for its heating element. When a negligibly small current passes through it, its resistance at room temperature. That means RT equals 75.3 ohms, and where T is 27 degrees Celsius, and this is room temperature. When the toaster is connected to a 230 volt supply, the current settles after a few seconds to a steady value of 2.68 ampere. Then I is 2.68 ampere. What is the steady temperature of the nichrome element? यानी बाद का ही temperature. The temperature coefficient of resistance of nichrome averaged over the temperature range involved is. That means they are talking about alpha. Alpha is given temperature coefficient alpha 1.70 into 10 raised to minus 4 degree per Celsius. So this was a alpha. And one more thing, what is the steady temperature of the nichrome element? Yani final temperature then T1, then T2 is to be found. But let's find baad ka resistance also. From this given data, R2 could be found. R2 equals 230 volt upon 2.68 ampere. That is 85.82. Now for T2, how do we find? Now considering for your, again I am to remind, RT is equal to R naught 1 plus alpha T. But here alpha at 0 degrees Celsius was not given. Alternative formula R2 is equal to R naught 1 plus alpha delta T has to be used. This is not to be used. Then coming back, this equation R2 is equal to R naught 1 plus alpha delta T. That means T2 minus T1, T2 minus T1, R2 minus R1 upon R1 alpha. So R2 is 85.8 minus R1 75.3. 75.3 into alpha. Alpha was 1.70 into 10 raised to minus 4. It implies that T2 minus T1 is 820 degrees Celsius. And already we had T1 27 degrees Celsius. Here you can notice. And we have to find T2 820 plus 27, 847 degrees Celsius. Now for example 3.4, again it is, the question is related to the relation between resistance and temperature only. Let's see what is given. The resistance of platinum wire of a platinum resistance thermometer at the ice point. At ice point resistance is 5 ohm, R not 5 ohm, and at a steam point, that means R100 equals 5.23. When the thermometer is inserted in a hot bath, the resistance of the platinum wire is 5.795 RT. Let's assume 795 ohm. Calculate the temperature of the bath. This time temperature is asked. Now again we would think for two relations. First is RT is equal to R naught 1 plus alpha T. Second is R2 is equal to R naught 1 plus alpha delta T. Now let's see what is to be taken. Point to be noted, no alpha is given. Applying. This is equation number 1. Second situation, RT is equal to R naught 1 plus alpha. So हम लोग जो थे, we had two equations. Finally, equation number 1 and 2. इन दोनों इक्वेशन से हमें T की वैल्यू निकालनी है. Therefore, T is equal to 100 into 100. What is RT? RT was 5.795. And what was R naught? R naught is 5. And what is R100? 5.23. Only calculation left. 5.795 minus 5. That is 795 upon 0.23. Get me the final value. 3.45 multiplied by 345. है ना? So T is 345.65 degrees Celsius. Hence, this is done. See you in next video. Bye for now. Take care.